Good day. My partner is Miguel Ángel Niño, and my name is Nicolás Potier. Today we are going to talking about a heat pump, his properties, and his components. A heat pump is a device that transfers heat energy from a source of a heat to what is called a heat skin. Heat pumps move the thermal energy in the opposite direction of spontaneous heat transfers, be according heat from a cool space and releasing it to a warmer one. A heat pump uses a small amount of external power to accomplish the work of transferring energy from the heat source to the sink. The most common design of a heat pump involves four main components: a condenser, an expansion valve, an evaporator, and compressor. This is important because it allows the fluid to change its direction, a positive direction. According to the USEPA, geothermal heat pumps can be reduced energy consumption up to 44% compared with the air source heat pumps and up to 17, 17.2 compared with a resistant heating. The COP for a heating pump is a heating or cooling application when a starting state operation is. COP heating equal delta Q, that is amount of heat extracted from a reservoir at temperature hot, over delta to area. This is equal to the temperature hot over temperature hot minus temperature cool. And the COP to cooling is equal to delta Q cool over delta Q area. That is equal temperature cool over the temperature hot minus temperature cool. This is the coefficient of performance, COP, increases as the temperature difference is a leaf. Decreases between heat source and destination. The COP can be maximized at the design time by choosing a heating system requiring only on low final water temperature and be choosing a heat source with a high average temperature. Lowering device, also called a metering device. This is a valve of expansion. This is more important. It has four components. This one makes the fluid to take several ways. With the use of a switch on off. These valves allow the low the pressure and its consequence it downs the temperature of the fluid. The change of direction makes the fluid to be consist changing the proportions in order to warm or cool rooms. It is important to say that the mechanical energy conversion is oval. Normally, the fluid used are refrigerants.
Mechanical heat pumps exploit the physical properties of a volatile evaporating and condensing fluid known as a refrigerant. The heat pump compresses the refrigerant to make it hotter on the side to be warm and releases the pressure at the side where the heat is absorbed. A simple diagram of heat pump's cycle is condenser, expansion valve, evaporator, and compressor. The working fluid in its gaseous state is pressurized and circulating through the system by a compressor. On the discharge side of the compressor, the low and highly pressurized vapor is cooled in a heat exchanger called a condenser until it condenses into a high pressure, moderated liquid. The condensing refrigerant then passes through a pressure lowering device, also called a metering device. This may be an expansion valve, capillary tube, or possibly a work extracting device such as a turbine. The low pressure liquid refrigerant then enters another heat exchanger, the evaporator, in which the fluid absorbs heat and boils. The refrigerant then turns to the compressor and the cycle keeps repeating until it is stopped. This is the diagram of the heat pump entropy refrigeration in where we see how the entropy looks in this cycle. So between 1 and 2 we have a adiabatic process in where the entropy is constant. This is when the liquid passes through the compression. Then it goes between 2 and 3, where we have the anisobaric process, where these are the diagrams for the refrigeration and the heat cycle for the heat pumps. Where we see in the refrigeration, we have between 1 and 2, we have a compression process, an adiabatic process, where the entropy is constant. So the vapor is saturated and it goes to a superheated vapor. Between 2 and 3, we have a compression valve and it's an isobaric process. Between 3 and 4, we have the refrigerator and it is an isobaric process too. And between 4 and 5, we have the compressor and it is an expansion process. In the heat cycle, we have the same process, but in this case, we have the heat in entering through the Rankine heat cycle. We have the heat in entering to the condenser and it goes to the opposite way of the refrigeration. So the heat enters and goes through the opposite to make a cooling of something, a room or a space we need. The COP, the coefficient of performance, this area increases in the COP is the energy that administers the source over the energy consumed by the pump. So in this case, we can have a coefficient of performance over 5 to 7. That means in a case where we have a COP of 3, that two times the energy is the energy that we can suminister to a system external, to an external system. And the other part is the energy that is consumed by the pump.